again. Now we move forward to talk about ramps. Ramps are simply sidewalks as inclined planes. Here, again, we'll go through a few design guidelines for ramps about their width, gradient, length, and configuration, and cross slope. So the first guideline, the width of a ramp should be determined based on their function and design intent. They should be at least 4 feet wide to allow 2 and more people to pass at the same time. And this is excluding the space taken up by the handrails, if there's any. Okay, so the usable width should be at least 4 feet. Next, slopes of ramps for pedestrian use should be between 5 and 8.3%. 20-to-1 slope to 12-to-1 slope, okay, with handrails required, usually on 5% slopes and greater. Again, check local guidelines to see if handrails are required. In some cases, if handicap accessibility is not a design consideration, the ramp can be as steep as 7-to-1, but that's not what we require in this class. Third, in terms of length and configuration of a ramp, if the ramp exceeds 30 feet in length, a level landing area is required to break down the ramp into multiple segments. Note that the level here is in relative terms. The landing itself should also drain at a 1 to 2% slope. In addition, a landing is also needed whenever the ramp turns a direction. There are quite many other requirements about ramps that you'll encounter, probably not this semester, but next semester for your stormwater class. So we won't get into much more detail now, for instance, about the dimension requirements of the landing, but we have provided this ADA standards for accessible design as a resource on Canvas. When necessary, you need to consult this PDF. The fourth guideline now, long ramps should be graded with a cross slope for drainage and safety. Ramps below 10 foot long usually don't have this requirement, okay? And this means that the contours across the ramp cannot be perfectly perpendicular to the edges of the ramp. This is wrong, okay, for the long ramps. They have to angle so that water can quickly drain to the side of the ramp. Not doing this will likely cause a sheet of ice to form on the ramp in winter, which can be very dangerous, especially for those in a wheelchair. So one other thing here you may have noticed is that unlike walls and steps, you do need to show the contours on any ramp on the plan, okay? In terms of spots, they need to be provided at the top and bottom of the ramp using TR, top of ramp, and BR, bottom ramp. The same principle applies here. Anywhere there is a slope, material, or geometry change, a spot is necessary. So here is an example of a long ramp in the plan view. You can see the inclusion of a landing area sloped at 2% where the ramp turns the direction, the design of a cross slope by angling the contours, the labeling of both the longitudinal slope along the ramp and the cross slope, and then the labeling of TR and BR at the top and bottom of each ramp segment. Notice that sometimes when you have retaining walls on the sides of the ramp, the bottom of the wall spot may be the same spot as the BR spot. In this case, you only need to label one of them. Like in this area, it is labeled as bottom of the wall and only bottom of the wall. Okay, only one spot is necessary. So this semester, you won't be designing long ramps yet, but what you will need to master is how to design curved ramps. This will come up in your project too. And here are the two major types of curved ramps you'll likely use in project 2. But we will not get into the details yet because they may not remain fresh by the time you take on project 2. So later on, we will have a detailed lecture on how to design these curved ramps. Okay? Lastly, like before, I just want to go over a few design examples to highlight that ramps, like walls and steps, can provide unique design opportunities, such as this one at the Olympic Sculpture Park in Seattle. This project used a series of ramps to form an uninterrupted Z-shaped platform that descends 40 feet from the city to the water. And you can see an existing road here that blocks public access to the waterfront. So these ramps rise over the road and reconnect the urban core to the revitalized waterfront. At the same time, these ramps capitalizes on views of the skyline and the bay. Here is another example by James Corner Field Operations. The ramps here, and you can also see steps, they work together to form an observation hill from which people can view the ocean and the pier on the right side. The entire hill was also designed as a noise buffer from the busy road on the right, so that you have a really quiet inner park. Then here are a few other quick examples that basically illustrate that while ramps and steps, they often appear at the same time in a project, good designs always try to seamlessly integrate them together. So this one is from Docklands, another one from Thames River Trail, London. Third is from the London City Hall. So those are some quick examples, and this concludes our brief lecture of ramps. Thank you very much. I'll see you in class.